Looking out across this wide expanse of the Kalahari Desert, the stakes for survival are immediately obvious. The sand is baked dry, the plains are flat, and water is virtually non-existent. Yet, growing right here on the scorching surface, we find this, a leafy, vibrant plant creeping across the sand, defying the extreme conditions around it. This is the devil's claw. This unassuming weed is the primary source for a massive medicinal trade, supplying more than 90% of the pharmaceutical demand for joint pain treatments in Europe. Producing this level of biomass and chemical value creates a significant biological contradiction. In an ecosystem designed to strip moisture away, the plant continues to thrive and expand. Survival here isn't about resisting the desert. It's about aggressively exploiting rare water sources and using the movement of the Kalahari's own inhabitants to spread. The first requirement for surviving prolonged dry spells is location. A plant needs a way to get its offspring out of the harshest, driest patches of sand and into slightly wetter microenvironments. This bizarre, woody object is the plant's fruit. It resembles a wooden spider, and its outer shell is covered in highly rigid, severely curved hooks. Those sharp hooks act as a specialized transport tool. When a grazing animal or even a vehicle passes by, the fruit latches onto the fur or the tires. The plant forces the passerby to carry its seeds across the desert. It is an aggressive, parasitic delivery system. By hitchhiking on moving targets, the plant ensures its lineage physically escapes localized droughts and spreads to new ground. But hitching a ride only solves half the problem. The real engine driving this plant's success is hidden safely out of the sun, deep beneath the desert sand. As this cross-section shows, the devil's claw splits its underground architecture into two distinct parts. There is a single, deep vertical taproot, surrounded by a sprawling network of horizontal, bulbous secondary tubers. Those thick, horizontal side tubers serve as the plant's internal canteens. They are biologically structured for rapid, high-capacity water absorption. On the rare occasions when the brief Kalahari rains actually fall, the plant aggressively hoards moisture and nutrients, packing them tightly into these secondary tubers. By dividing its anatomy this way, the plant keeps its critical life support system safely insulated from the extreme heat baking the surface above. That deep storage system becomes critical when the rare rains vanish and the desert returns to a state of prolonged, hostile drought. To conserve energy, the plant makes a ruthless calculation. It voluntarily lets its green creeping leaves wither and die, instantly stopping any further water loss from the surface. The core organism retreats entirely underground. In a dormant state, it slowly concentrates Harpagophytum, a powerful natural compound that reduces inflammation, safely in the dark. That creates an economic bottleneck. Because this specialized defense mechanism requires the extreme stress of the desert to concentrate those valuable compounds, it cannot be easily rushed or mass-produced on an industrial farm. Because the plant's potency is tied to these slow, wild survival cycles, it remains resistant to industrial farming. Global markets haven't replaced the desert. They have simply learned to depend on it. Look at this harvest process. The global supply chain relies entirely on indigenous workers, primarily the sand people, who harvest the plant manually. It is highly labor-intensive. Workers use small shovels to carefully dig deep into the sun-scorched, compacted sand, searching for the hidden water storage system. But as this animation illustrates, the harvest follows a strict ecological rule. The workers meticulously slice and remove only the horizontal secondary tubers. The central taproot remains completely untouched, left firmly anchored in the dry soil. Leaving that core biological engine undisturbed ensures the plant survives the physical trauma of the harvest. When the rains eventually return, the intact taproot simply regenerates a fresh set of horizontal tubers for future seasons. The devil's claw proves that true resilience happens out of sight. Tapping into nature's most durable resources requires us to work within the rules the desert has established, rather than attempting to conquer them.